In this video, you will learn about physical and chemical properties of matter, but we will also go over some basic concepts of writing elements and compounds. Okay, so when you write an element, it would always start with a capital letter, and it will consist of one or two letters. And if it has two letters, the second letter will be lowercase. Okay, so for example, here's copper, right? You see that the first letter is uppercase, the second letter is lowercase. Okay, gold, right? AU, uppercase, lowercase. And this slide also points out that some elements have symbols that don't really match their name that we know. Like copper, you might think, why don't we use CO? Well, that would be cobalt, but CO for copper, because copper, right, it's known as cuprum, right? This is the Latin word for it. And so it is Cu for cuprum. And gold, right, doesn't start with the G because the Latin name is aurum. Okay? Iron, right, for ferrum, right? So Fe, right? Silver, right, is Ag for argentum. And I like to ask the class, what country do you think has a lot of silver? So you can think about that for a second. Hopefully you came up with Argentina, right? So that has the argentum in its name. One of my favorites, not on this slide, is the symbol for lead, okay, which is Pb, which stands for plumbum. And that was Latin for waterworks when they used lead pipes, right? Pb, plumbum. Okay. Chemical formulas. So how we write formulas to show the number of atoms that are present, we use, right, a subscript. Okay, so the subscript, right, so that is like the 2 there. So for water, H2O means in a water molecule. So if we draw out a water molecule, we have a hydrogen connected to an oxygen. You'll learn how to do this later. Connected to another hydrogen. So in a water molecule, there's 2 hydrogens. So that's for the 2, and 1 oxygen. We don't put the 1, we assume it to be 1 if there's no number there. The next one looking over here is CH4. That's methane. So methane, that's a gas, that's natural gas, has a carbon bonded to 4 hydrogens. Okay, so CH4 means 1 carbon, 4 hydrogens. And this is sucrose. I'm not going to draw that out, but you would see here that you have 12 carbons, 22 hydrogens, and 11 oxygens, right, in that large molecule. Okay, so remember that number. This number is called a subscript. Symbols that you'll see, right, in this course. Here's an example. This is for water. So when you see just H2O written, that's known as the molecular formula. Since it's a molecule. When we draw it out, that is the expanded formula, so showing all the bonds. And sometimes you'll see the representations with the ball and stick. These look like molecular models. And the more realistic appearance is called the space filling model. So with the electron clouds filling in the space filling model. And so these are all symbols you'll see in this course. Okay, and you'll learn the colors. Red is for oxygen, white is for hydrogen. Okay, so let's do a little practice using the space filling model and going back to what we learned in the last video about classification of matter. Okay, so looking at number 1, you see that you have molecules here. They're all carbon monoxide molecules. Carbon is black, right? But every single one of those is a CO, right? So that would be, right, B, right? Just a compound. Maybe I'll circle that. Okay. Looking at number 2, right, those nitrogen molecules, but it's N2, it's pure nitrogen. And so that is A, right, for element. And then in number 3, we see a mixture here, right? We see nitrogen and carbon. We see a mixture of elements, right? So that's C, choice C. And then number 4, you can see element and compound, right? And so that is a E, a mixture of elements and compound. And then in 5, that's a sulfur trioxide and a carbon monoxide. So that's a mixture of compounds, D. Okay. Okay, states of matter. Okay, so the 3 states of matter are solid, liquid, and gas. And solid, and we'll say that this has a definite shape, okay, and volume. Okay, so this example is showing ice here, using water as our example. So if you think of solid ice, you know that it could have a very specific shape of like an ice cube. And the space it occupies, its 3-dimensional space, right, is a definite volume. The particles are fixed. Particles are fixed in place. They're not free to move around, right? They're kind of stuck in a solid. Then you go to liquids. If you took solid ice and you start to warm the ice, it'll start to turn into liquid water. And as you can see here, you can see that there's no like organization to these molecules. Here it's a very structured organization because they're fixed. So these molecules are flowing over each other. But what we do say that they have a definite volume, but they don't have a definite shape. So definite volume, indefinite shape. So for example, if you had a cup of water, right, that's a definite volume, right? 8 ounces of water. And you can put that 8 ounces of water into a bowl. You can spill it on the floor. You can have it in a glass, right? So the shape can change, but the amount of liquid water, the volume, was the same. Okay, so definite volume, indefinite shape. Particles are free to move. To move about. Okay. But they're still very close together. Okay, and then you look at the gas phase, and this is an indefinite, right, shape, right, and volume. Okay, because it depends upon the container. Gases are very far apart from each other. They're moving around quickly, and so you can't really contain a gas unless you have it in a container. So gases will take the shape and volume of their container. Okay. And the particles, right, are in constant random motion and are very far apart. A good analogy is if people were gas molecules, the next gas molecule nearby would be about 4 miles away. Okay, so that's how far away they are from each other. You should also learn these terms if you don't know them already. So if you are going from the solid phase, okay, so here we'll write, this is solid, right? To go to the whoops, what did I do? Go to the liquid phase. Let me put it. And then to the gas phase. Okay, so you can change states of matter. Okay, so going from solid to liquid, right, you would melt it. The word is called melting. And then from liquid to gas, okay, so if you're thinking of water, like liquid water to steam, okay, that would be evaporation. Okay. Now going in reverse, so going from gas to liquid, that's called condensation, and liquid to solid is freezing. There are some substances that would go directly from a solid to the gas phase, skipping the liquid phase, and that term is called sublimation. An example of something that you might know is dry ice, right? Solid carbon dioxide. It goes directly from the ice to the steam, to the fogginess. Okay, and then going back from gas to solid directly is called deposition, like depositing. Okay. So now let's discuss properties of matter. Physical properties, right, versus chemical properties. Okay, physical properties can be observed without changing the substance. Okay, so without carrying out a chemical reaction. So we're just observing, right, a substance. So what are some examples, right, of physical properties? Let's just use a different color. It might be the color, right? You could observe a color. You might have an odor. You can pause the video and think of some yourself. We talked about metals. We talked about if they were lustrous or not. Another thing we use is to describe substances would be its boiling point, right, or melting point. Can they conduct, right, heat or electricity? I'll just put conduction. Right, so those are some examples of physical properties. Chemical properties, though, explain or they tell you what kind of chemical reactions it might undergo. So a chemical property might be something like, oh, that substance is flammable, right, that it can burn. Can it oxidize? So you might think of like your bike rusting, that's an oxidation reacting with oxygen. Right? Other things that might happen is releasing heat, right? Will it release heat, right? Or light? Some reactions produce light. It could also absorb. So I guess we could say it could emit or absorb energy. Okay. Right, so those are some examples of chemical properties. What type of chemical reactions a substance is likely to undergo. And so a physical or chemical change, right, is describing a change in its appearance, right? A physical change is a process that changes one of the physical properties, but without changing the chemical composition. So something, for an example, might be like ice melting. So you're changing it from the solid state to a liquid state, right? You've changed the physical appearance about it, but it's still, right, H2O, right? Nothing happened to the substance, right? Still H2O. A chemical change involves a chemical reaction, and that is going to change it into a new substance. So like we mentioned before, we could take H2O and we could put in energy and we can change it, right, into its pure elements. That's a chemical change. So anytime a chemical reaction occurs, right, that's a chemical change. Let's do a little practice here. Okay, so in number 1, we're seeing ice, that's dry ice, and we're seeing it going from the solid state to the gas state. So that is a physical change. In number 2, right, that's the famous Hindenburg that exploded, a blimp. And what we're seeing is an explosion, right? So we see a chemical reaction occurring. It was the burning of hydrogen gas. So that is a chemical reaction. And in number 3, we're seeing a penny, the copper on the outside of the penny turning green, and that is an oxidation reaction. This is just like the Statue of Liberty turned the greenish color. So that is a chemical change. Okay, so again, try this on your own first. So pause the video and just decide whether you think it's a chemical or a physical change. Okay. All right, so campfire, right, that is a chemical reaction. That's a combustion reaction. Silver tarnishing, that's a chemical change. A broken test tube, that's a physical change, right? The glass did not change in composition, right? Rotten tomatoes, chemical change. Melting iron, like in the picture, that's a physical change. You're taking a solid and turning it to a liquid, but it's still iron. Boiling water, going from liquid to steam, right? That's still water, so it's a physical change. And combustion of methane, like in your stove, right? That is a chemical change.